Hey, good morning. Welcome to the 5 a.m. Mester Scrum Show. Hope you're doing well today. Happy Monday. It's a cold Monday here in the East Coast. It's kind of cold. The football games tonight are going to be crazy. But since we're talking sports and all, I want to make sure I did a Metric Monday episode. We talked about some metrics. And I wanted to rehash, and I realized that green highlighter or dry erase markers do not work on video. They don't work. So I had to use a little bit of red in there, maybe black all the way. We'll see how it goes. I'll use red and black to do it on the graph, but we're going to look at velocity versus acceleration. And I'm going to say it. You can use acceleration to compare teams. Depends what you're looking for. Are you looking for team growth, progress, where they're heading, in what direction? Acceleration, you can't use velocity because velocity is determined by each team. However, acceleration is team independent. So you can compare teams based on acceleration if you're looking to see if your team is growing and improving their process. If you don't care about whether or not your team is improving their process, then you don't use acceleration. And we're going to talk about that today because it is a Metric Monday. I always like to bring a metric in. I'm going to revisit this, and I talked about this a few because this is something I do, and I don't see a lot of other organizations do it or a lot of other people do it. But this is an acceleration thing that you can measure, track, and you can make it automated. It's really easy to do. So with that, it's the 5 a.m. Mester Scrum Show. I am Greg Mester, Scrum Master and Agile Coach. Here we talk about Scrum and Agile in a very practical and tactical way so you can bring more value to your customer, not work crazy hours to bring that value to your customer and have a little fun along the way. And I had a little too much fun watching the kids do their things this weekend. It was fun. A lot of hockey, a lot of baseball, a lot of activities, a lot of reading for myself. I did a lot of, I got some goals I want to finish. I got 20 pages left in the book. So I'm probably going to read that today and finish that darn book. Get it done, quote, done. Anyway, so acceleration velocity. Everyone wants to compare big corporation. I want to compare the velocity of one team to another. Well, you can't, right? Because everyone establishes how they want to measure things, how they size things. They could use bigger numbers, smaller numbers, whatever. They all look at it differently. There's different work. There's different process, different software, different coding, different methodologies. Some include, UAT testing with the customer. Some do not. So it's kind of hard to compare that. Now, what you can compare, and we're going to do that today because it's, everybody wants to know some metrics and some things that people don't do. We're going to look at velocity and we're going to look at acceleration. So I'll use a black pen for velocity, and I'm going to use a red pen for acceleration because the green pen, which I have, does not work on a whiteboard, on TV, on the video. Doesn't work. No, doesn't do it. So, and I know today is Martin Luther King's birthday. It's a holiday and everything. That's why I don't have to teach the kiddos. What I am going to do, we'll talk about team diversity on Wednesday because that's Team Wednesday. So we're not going to talk about it today because there's enough out there, but I will talk a little bit about diversity and things like that on Wednesday. And I have a slightly different take on it, but maybe we'll bring that up. It'll be a good conversation. Okay, so we got velocity. So as you know, let's say, I want to do it two ways. So when we do velocity, team always think they can do more they can product understanding. So I want to put a little triangle for what they do, okay? And I want to put a star for what they actually accomplish. Did you notice the velocity for what they do is way below what they think they can do? That's the way it works. So what happens is they'll come down. What they should do in the next sprint is they should maybe estimate a little bit above what they did before because they're just getting things hashed out. So it'll be a higher, but then they actually produce more. Okay, they actually produce more of what they pick. And then they're going to say, oh, cool, let's pick that. But I always try to get them a little lower if they're smart. Do a little lower. And they actually perform a little bit less. They come down. Okay, so you have this kind of thing going on. And then by the time they get to the fourth sprint, You get to the fourth sprint there. They're pretty good. Usually they're what they predict and what they do are probably right on each other. Okay. So maybe I use the green one, even if it doesn't work. And I'll use it that way. So it kind of looks like that a little bit. Okay. And it goes across. So now you hit a stable point. Once you hit the stable point, you can use acceleration. Okay. This is trying to figure out what their norm is. Maybe the next sprint, maybe the fifth sprint, they're a little bit better because they're doing retros. So they're there, right? Ideally, what you can measure, now you can't measure each one, right? So let's say, and I'm gonna assume they get better, okay? Because any team, if they're not getting better after the fifth sprint and improving with the retros, when you got a retro problem and they're not trying to improve, okay? That's something to work on. So let's assume they get a little better. And then the seventh sprint, they get a little better. Okay, so now they start heading upwards, right? So now they're like that. Now you can have it. Well, maybe they get better a couple sprints, and maybe we'll use the red one. Black goes up, red goes down. Maybe they start going down. And maybe they start going down like that. So you get two ways. So this is acceleration. Excel going down. And this is acceleration going up. So you get that, right? I don't know if you can see it, but you get this. So you get acceleration going up, the velocity going up, acceleration going down, right? So now, why do I say you can automate this? Because it's just math, right? And the reason why I use acceleration, well, I was an engineer, mechanical, and did a lot of tech, computer stuff because learned a long time ago you couldn't do the computer stuff. You couldn't really get the mechanical stuff to win without knowing the computers. That's how I learned how to play program software. Was to build mechanical and spaceships and stuff like that. So you got this. So all this is the mathematical formula, right? So it's a change of velocity. So you basically got velocity of sprint 1, and you could do no, actually do it this way. Velocity of sprint 2 minus velocity of sprint 1 divided by 2. Right? So acceleration is the change in velocity, right? You could do a simple math problem. You could do a division. I would do the division part only because it talks about the average percentage. Now, what I would, you know what? What am I doing? I don't want to divide 2. You know what I want to divide by? I want to do V1. Let's do this right. So I got V2, which is the second sprint velocity, the next one, minus V1, which is the previous sprint, divided by sprint 1, okay? This is going to give you a ratio or percentage. So let's say velocity 2 is 110. Velocity 1 is 100. Divide by 100. So that gives you my equals 10 over 100, which is 10%. So I had to go down a little bit. So we got velocity 2 minus velocity 1. So we got 110 minus 100 divided by velocity 1, right? So that's 10 over 100, which equals 10%. So you have a 10% acceleration. The reason why I do this divide by the velocity, because that negates the units. That negates, it makes it a normalized number. So that normalized number can be used to compare teams if you really want to compare teams. If you're looking at a new organization, got a couple teams that's spinning up, are they all growing? They not growing? Are they maintaining? Are they level? So if they stay at 100 and divide by 100, they got 0, right? So if they had 100 and they went down to 90, it would be a negative 10%, right? So that's how you can do your acceleration. That doesn't care what units or how they measure it, because even if they did apples, one's oranges, right? So one team has apples, one has oranges. It's still percentage. So let's say one team, their first sprint, their second sprint, they had 2 apples. And second sprint, they had 1 apple, and they had another apple. So it would be a double, right? Right? Or 1 over 1%. I guess it would be 1. 2 minus 1 would be 1 over 1 would be 1. So it's still the same. I might have to do that a little different. Anyway, but that's the idea of the velocity. So I guess if it's 1 minus 1, 100 minus 100 would be 0. 0 divided by 100 is 0. Yeah. Okay. Anyway, so you got a 0% change. But if it was, let's say 3 apples, 3 apples minus an apple or whatever, you can compare that. Same with oranges. It's a percentage, right? It's a normalized number to go over top of that. So the idea is that you could theoretically compare teams based on if your company's goal is for the teams to grow and get faster, right? If that's what you're looking for and comparing your Scrum Masters, your teams, use acceleration, but you only use it. And this is the thing. And once you hit the normalized position, it's just like in statistics. Once you figure out your average, your mean, and you make a change. Remember in, I want to say quality assurance. What was I was studying something? I can't remember what it's called. Anyway, but the statistics, when you do changing, when you're doing quality checks and process improvement, when you do the process improve SPC, if you remember SPC, when you do SPC, you make a change. That's your retro. Propose a change. Does the change make the acceleration go up or down? Right. And then you start measuring based on when you figure out your average. Did you impact or not impact how the average was doing? And that's when you start measuring that acceleration. So I wanted to share that with you. I had to double check my math, but that's basically it. So it becomes a unitless number, and it becomes a percentage. Now with this percentage, like I said, you can actually compare teams if you really need to or really want to, but you can also use it to see, are we improving the process? Are we staying the same? Where are we at on that? It's a good number because you get that shark's teeth kind of mentality. Like when I show this picture, we talked about shark's teeth many shows ago. You get the shark teeth. The acceleration is usually a much smoother thing, unless they are going up and down, then it really doesn't matter. But it's a good way to see how the team is doing over time. With that, I want to say you have a great day. Happy Monday. Stay warm, and we'll see you tomorrow on 2 for 1 Tuesday, or what I call it 10xing your career, 10xing your team. We'll do that tomorrow. With that, I say take care, have a great day, and see you tomorrow.